Hello students, I am Vibhav Gupta from Narayana Educational Institutions. Today we are going to discuss JEE Mains 2024 30th January afternoon session question paper. This is a memory based question paper, so there may be some errors. Let's start the discussion. So this here is the first question of the exam. So here we have a block which is being ascended up an incline by a distance of 10 meter as they have shown. Here they are asking for the work done against the friction. So if we draw the free body diagram of the body, we'll have component of mg down the incline, component of mg perpendicular to incline, normal force, and the externally applied force which they have showed to be 10 Newton. As the block is moving up, the friction on this one will be downward. As it is moving, it will be kinetic in nature, and the value is going to be mu n, which is equal to mu mg cosine theta. Now, work done against friction is equal to negative of work done by friction. So as you can see, the block is moving up and the friction force is downward. Work done is going to be minus of, because they are opposite in direction, mu mg cosine theta, which is the friction force, into displacement s I'm writing. So this becomes mu mg cosine theta s. Now value of mu is given to be 0.1, m is given to be 1 kg, g is 10. Now theta is not mentioned here, but we looking at the options, we can expect it to be about 60. So cosine 60 is going to be half, and displacement is said to be 10 meter. So our final answer comes out to be 0.1 and 10 gone. Now we have overall 5 joule. So option 3 is our answer. Going to the next question. So here we have 3 blocks being pulled by a force. They are being asking for to find the tension. Now we know that sigma F external on any system of particles is equal to total mass into a system. The total force acting on the system is 10 Newton, and total mass of the system is 10 kg. So from this we can figure out the value of system's acceleration, which comes out to be 1 meter per second square. Now if we look at the 2 kg block, I can draw the FBD. So we have T1 and 3 kg block. We have T2 and T1. Now all 3 blocks are moving to the right with the acceleration 1 meter per second square, as we have found earlier. So from this you can see T1 is equal to m, which is 2 into acceleration 1. That gives us 2 Newton, and T2 minus T1 is equal to mass, which is 3 into acceleration 1, giving us T2 is equal to T1 plus 3 Newton, and thus T2 being equal to 5 Newton. So T1 is 2, T2 is 5. So giving us option 1 as our answer. Going for the next question. Now this is about photoelectric effect. They're asking for the slope of the stopping potential versus frequency of incident photon graph. Now, if you remember Einstein's photoelectric effect equation, so that is FHF is equal to K max plus phi naught. Phi naught is the work function, F is the frequency of incident photons, and Ke max is the kinetic energy of the electrons coming out with maximum kinetic energy. Now, HF, now kinetic energy maximum value I can write down as E into V stop, stopping potential, plus phi naught. As they're asking for stopping potential versus frequency, I'll rearrange the equation and write down minus phi naught, giving us V stop is equal to H over E into frequency minus phi naught over E, where E is the charge on the electron. If you look at this, we are trying to find out graph. If you compare this equation with y is equal to mx plus c, you can see here the slope comes out to be h by e, and y-intercept comes out to be minus phi naught by e. Anyway, we are supposed to answer for slope, so our answer is going to be 1. Moving on to the next question. This is question based on calorimetry. Ice is being heated from 10 degrees minus 10 degrees Celsius to eventually to steam at 100 degrees Celsius. So if we draw the phase, uh, how the phase progresses basically. So we have ice at 0 degrees Celsius, actually ice at minus 10 degrees Celsius, and we are heating it up to ice at 0 degrees Celsius. If we heat further, it will convert to water at 0 degrees Celsius, and thus further if we go heating, it becomes water at 100 degrees Celsius, and then it converts to steam at 100 degrees Celsius. So notice that in this part, temperature changes. Temperature changes or increases. And in these parts, temperature remains same. During phase change, we don't observe any change in temperature. As you can see. So if I draw the graph here, so we are starting off from negative temperature, going to 0. Then temperature remains constant till it converts to water. Then water starts to heat up, and again temperature becomes constant as it starts to convert to steam. So here we have ice. Here we have water. Here ice is converting to water. Here water is converting to steam. So in this case, our answer here is going to be option B, or the second option. Moving forward, fifth question here. So we have two particles being projected from a tower of height 400 meter. Angles of projections are given as 45 and 60 with the horizontal. So, and they're saying that the time of flight is same, find the ratio of their velocities. If I draw the tower here, so a particle is being projected at 45, another is being projected at 60. I'll name the velocities as v1 and v2. Now, the time of flight depends on time of flight depends on vy or y component of the velocity. All right, like that. So because the time of flight is same, so we'll equate the time of flights. So v1, this is v2. Now v1 theta 1 theta 2. So v1 sine theta 1 should be equal to v2 sine theta 2, giving us v1 over v2 is equal to sine theta 2 divided by sine theta 1. Now the values are known to us. So v1 over v2 is equal to theta 2 is given as 60 degrees and theta 1 is given as 45 degrees. Values are root 3 over 2 and 1 over root 2, giving us v1 over v2 is equal to root over 3 by 2, giving us the answer as 1. Moving to the next question. Now this is based on current electricity. If you look at the question here, now voltage in this part is given to be 1 volt, and voltage in this part, obviously because the battery is there, so out of 5 volt 1 volt is there, remaining 4 volt will come here. I'll assume some currents, I1 through the voltmeter and I2 through the lower resistor, giving us total current I1 plus I2 through the 2 ohm resistor. Now because the values are given, I can take I1 into resistance of the voltmeter should be equal to I2 into 100 ohm, because they are connected in parallel, and this voltage is given to be 1 volt. Now this relation gives us that I2 is equal to 1 over 100 ampere. Now we need to figure out I1 plus I2. So an I1 plus I2 into 200 ohm. This voltage we figured out that it is equal to 4 volt, giving us I1 plus I2 is equal to 4 over 200 and thus 2 over 100 ampere. 2 over 100 ampere, like this. Now I2 value is known to us, so this implies I1 is equal to 2 over 100 ampere minus I2, which is 1 over 100 ampere. Finally we are getting 1 over 100 ampere. Now, once we know I1, from the same equation we can get RV is equal to 1 volt divided by 1 over 100 ampere, giving us RV is equal to 100 ohm. So answer is first one. Moving forward, we have a question here where we have silicon and germanium diode connected in the forward bias as they have shown, and we are supposed to find out voltage or potential difference across 2.5 kilo ohm resistor. And this question is conceptually similar to the previous one because they have said that voltage across this one is 0.7 volt and voltage across germanium one is 0.3 volt. Now, total voltage across the resistors here. The total voltage across the system is 15 volt, out of which 1 volt, 0.7 plus 0.3. 1 volt has been taken by the diodes. So remaining 14 volt stays here. Remaining 14 volt stays here. Now, so current through the circuit, if I mark current through the circuit, some I. Now, I is going to be equal to 15 volt, the total voltage, minus 0.3 volt across the germanium one, minus 0.7 volt across the silicon one. That's the total voltage difference over the total resistance of 2.5 plus 1.5 kilo ohm. Now, potential difference across 2.5 kilo ohm resistor is going to be the current into the resistor, giving us the current comes out to be 15 minus 1, that is 14 volt, divided by 4 kilo ohm multiplied by 2.5 kilo ohm, giving us 7 over 2 multiplied by 5 over 2 volt, that is 35 by 4 volt, which is equal to 8.75 volt. Thus, our third option here is correct. Let's move on. Eighth one, we have a point source which is placed at the origin. Intensity at a distance of 2 centimeter is from the source is given to be I. They're asking for intensity at double the distance. Now, for a point source of power P, it is spreading spherically, symmetrically. So, at some distance R, intensity can be written as P over 4 pi r square. P over 4 pi r square. Now, because the whole energy is being spread over a spherical surface. Now, you can see here from this, if I talk about some I prime for the same source, that's why powers P, but at double the distance. So, I prime here comes out to be P over 4 pi r square, 1/4 of that. Now, the term in the brackets is equal to actually I, so we get I by 4. So, that's the third option. It's a very easy question. Now, looking at the next question, we have, as the graph suggests, we have a polytropic process, you can see, which can be represented by the equation PV raised to power x is equal to constant, where x is known as polytropic coefficient. Now, if we differentiate this respect to V, volume, differentiating with respect to V, I'll get P V raised to power x minus 1 plus dp by dv, applying chain rule here, is equal to 0. Now from this I can cancel this v raised to power x and this 1v will be left there. So from there we get dp by dv is equal to minus of x times p over v. Now if you look at this, the slope, this here is the slope and this here is polytropic coefficient. All right, now you can see the slope is equal to x times p by v. So larger the x value, larger the slope, the steeper the curve. So larger the x, steeper the curve. Now in this case you can clearly see that a is a steeper curve. So in case of a, the exponent should be larger. In case of a, the exponent should be larger. So from here you can figure out. So in option A, you can see for a, exponent is smaller because gamma is given to be 1.5. In B, if you look at, again exponent of in case of a is smaller. I want the exponent in case of a to be larger because that's a steeper curve. Looking at third option, there we have exponent of v here, x as 1.05, while for B it is gamma which is 1.1 as they have given. So third is also wrong. Correct answer is going to be the fourth one. Moving on, we have a voltage source. They're asking for the current time required for current to go from I by 2 to the I naught value. Now writing the current value is V over R. Thus it gives us I is equal to 200 sine 100 pi t divided by 5 ohm. This is in volt. Now, but again, they're asking for the time. Now, looking at this here, we can relate this 100 pi thing as omega. From here, angular frequency of the function here is 100 pi. Now, we want the current to go from I naught by 2 to I naught. So, if I go further, I write down 40 sine 100 pi t ampere. Now, for this value to be I naught by 2, I want this phase value for I naught by 2, 100 pi t needs to be equal to pi by 6. For I naught, 100 pi t needs to be equal to pi by 2. So total phase change. So total phase change or angle turned by the phasor, as you can see, is equal to pi by 2 minus pi by 6, which is pi by 3. Actually, it's 2 pi by 6 equal to pi by 3. Now, for the phasor to turn by pi by 3, time is going to be equal to delta phi divided by omega. So pi by 3 divided by omega is 100 pi, giving us time as 1 over 300 seconds. So option 1 is the correct answer. Moving on, looking at this question. So a nucleus of mass m is breaking into 3 nuclei with mass defect equal to delta m. And the daughter nuclei, they all have the same equal mass basically. Assuming the nucleus, the parent nuclei, to be at rest. So the three parts, if they are going away, they are equal mass. So momentum needs to be conserved. So they all must be going at 120 degrees from each other, like this, in a plane. Now, total energy released here is delta mc square. Total energy released here is delta mc square, which will be equal to total kinetic energy of the system here. Now, kinetic energy is going to be half m minus delta m, mass of a daughter nuclei. Now, delta m is the total mass defect. So, we'll have to write down the mass as 1/3 of this value into v square. Now, we have three such nuclei. So, m minus delta m is the total mass of the daughter nuclei. 1/3 of that is the mass of one nuclei. So, this is kinetic energy of one uh, daughter nuclei multiplied by 3 for 3. Here, if we continue, I'll get delta mc square is equal to m minus delta m v square by 2. So, speed of each 2 delta m c square divided by capital M minus delta m is equal to v square, giving us eventually v is equal to root over 2 delta m divided by m minus delta m c. So the correct answer here comes out to be option 2. Moving on, they're talking about a vernier caliper having 49 main scale divisions equal to 50 vernier scale divisions. So 49 main scale divisions is equal to 50 vernier scale divisions, giving us one vernier scale division equal to 49 over 50 main scale division. Now, least count, or the vernier constant you can say, will be equal to 1 MSD minus 1 VSD in this case, giving us 1 minus 49 over 50 MSD, which is equal to 1 over 50 MSD, and 1 MSD is, they have said, 0.5 mm. So the least count being equal to 0.01 mm, giving us the first option. Like that, we can move on. Now, some energy is incident on a surface in term time delta t for the total momentum imparted. Now, total momentum imparted is equal to number of photons multiplied by momentum imparted by each photon. Now, number of photons we can find by the energy. Now, total energy E divided by energy per photon, which is hc by lambda. Now, this term here gives us the number of photon. Total energy falling divided by energy per photon, multiplied by momentum imparted by each photon, because the collision here is said to be completely absorbing. So momentum imparted is h over lambda. Therefore, total momentum imparted comes out to be equal to E by C. So to calculate the answer here, we can do 6 into 10 raised to power 5 joule divided by C is 3 into 10 raised to power 8 meter per second, giving us 2 into 10 raised to power minus 3 SI units, which is kg meter per second. So first option here, simple question. Now next we have a particle which is placed in a parabolic curve, and we are placing it at a certain position. Now what is the maximum y above the x-axis so that it does not slip? Here we can think in terms of angle of repose. So if you know, if we have some inclined plane and we place some object on that, the maximum angle at which it will not slide is called as angle of repose, and tan theta comes out to be equal to mu. You can do that by drawing the FBD. Mg sin theta, the upward friction force is going to be mu mg cosine theta. Now at the maximum angle, it is just about to slide. That's why the friction I have put as maximum, which is mu n. Now mg sin theta is equal to mu mg cosine theta, giving us tan theta is equal to mu. Now tan theta in this case will be the slope of the curve. Now y is equal to x square by 4 is given. Dy by dx is equal to 2x by 4, which is equal to x by 2. Now we want to equate slope with the coefficient of friction, which is gives us x by 2 is equal to 1 by 2, giving us x is equal to 1. For x is equal to 1, I get y is equal to 1 by 4. Therefore, option 1 being the answer. Next, we have two Polaroids here, and the angles are said to be at 45, the first one, and we have unpolarized incident on the first Polaroid here. Now, this is a very simple question. Now, when unpolarized passes through a polarizer, the intensity becomes half. So, I naught by 2. And then we have the next polarizer. The intensity in that case is going to be I naught by 2 multiplied by the cosine of the angle between the polarizers. Now, the final intensity coming out is I naught cosine square 45 degree, giving us I is equal to I naught by 2 1 over root 2 whole square. Thus, we are getting I is equal to I naught by 4, giving us option third as the answer. Move on. Now we have two vectors here. They have said a vector is having magnitude equal to that a vector and is parallel to that vector. Now the components given are 3 and x. So we have some c vector whose magnitude is equal to magnitude of a and direction is parallel to b. So c vector, if I write down, so magnitude of a comes out to be 4 square plus 3 square root, and the unit vector is going to be 3 I cap plus 4j cap divided by magnitude of this vector, which is again 3 square plus 4 square. The c vector coming out to be 3 I cap plus 4j cap only, which is b vector itself. One component is given as 3, the other component is 4. Other component here is 4. Thus, 2 being our answer. Let's move on. Now we have mass given as some power relation between C, G, and H here. Now, writing dimensionally, dimensions of m here are this. Dimensions of c is the speed of light, so dimensions are going to be L t minus 1, whose power is given as p. Now g is the gravitational constant, whose dimensional formula we can find by Newton's law of gravitation. So giving us g is equal to mlt minus 2 for the force, L2 for r square, and m2 for m1 m2. This being equal to m minus 1 L3 t minus 2. So we have m minus 1 L3 t minus 2 raised to power minus half. Now h bar here. So from Bohr's quantization principle, we know that mvr is equal to nh over 2 pi or nh bar here. Now dimensionally, if you look at it, is equal to mvr, and n is just a numerical. So dimensions of h will come out to be m for mass. Velocity will have Lt minus 1, and we have one more L because of the r. So L2 t minus 1. Let's put it here. I get ml2 t minus 1. So finally I can write down m here, and this also has exponent half. So overall we get m plus half of this from the second term and plus half from the third term. So overall m lp minus 3 by 2 from the second term and plus 1 from the third term. For t, I'm getting minus p from the first, plus 1 from the second, and minus half from the third. For these to be dimensionally equal, p minus 3 by 2 plus 1 is going to be minus 1 by 2, and that should be equal to 0, giving us p is equal to half, which is 0.5. We can do that for t also. That gives me p plus half is equal to 0, again giving us p is equal to half, and thus 0.5. Answer being 0.5. Moving on, we have this question here. They have said that we have a square loop carrying a current of 5 ampere, and they're asking us to find the magnetic field at the center. Now, having a finite current carrying wire, if you want to find the magnetic field at this point, so B value here is equal to mu naught I divided by 4 pi r sine theta 1 minus sine theta 2, where theta 1 and theta 2 are the angles here taken to be with sign. Now, in this case, if we look, we have this square. If we simply focus on one side here, so these angles come out to be 45 and 45, and this distance here comes out to be half of the side, which is 0.5 meter. Now, magnetic field, because of one side, magnetic field net is 4 times the magnetic field because of one side, giving us B times mu naught I divided by 4 pi r. Now, theta 1 and theta 2 in this case are going to be 45 and theta 2 is going to be negative. It's on the opposite side, no? So negative, giving us sine 45 plus sine 45. So our answer being mu naught I by 4 pi r. Sine 45 is 1 by root 2 plus 1 by root 2 I get twice by root 2. Now to get the final answer, I'll get 4 times mu naught is 4 pi into 10 raised to power minus 7. Current is said to be 5 ampere divided by 4 pi, and r here is going to be 0.5, half of the side, and here we get root 2. 4 pi and 4 pi get cancelled. Here I get 10, giving us 40 root 2 into 10 to the power minus 7 Tesla. So x here is this, so that's 40 here. So answer here being 40. So simply we are looking at magnetic field to each part of the side, and then we are doing it 4 times of that. Next, they are saying that we have a planet whose mass is 1/6 of the mass of the Earth and radius is 1/3 the radius of the Earth. They're asking for the escape speed. Now, V escape here is equal to root 2 gm by r in general, if we say. Now, V escape prime, if we talk about, that's going to be root 2 g. Now, mass here is 1/6. Mass here is 1/6 divided by radius here is going to be 1/3. So I'll just put whatever the radius here is, giving us V escape prime is equal to 2 gm by r multiplied by 3 over 6. Finally getting as root gm by r. Now if you look at this, this value is equal to initial escape velocity divided by root 2. So our answer is going to be V escape initial by root 2. Now V escape prime is equal to, now this is given to be 11.2 kilometer per second, and I can write down root 2 as root 2 by 2 here, giving us 5.6 multiplied by 1.414. Now the answer here is, if you see, is coming out to be very close to 8. So nearest integer here we can put as 8. Multiplication we can handle. Now electron in the fifth cyclic state comes down to first cycle, number of possible spectral lines. So 1, 2, 3, 4, 5. Okay, n is equal to 1, n is equal to 5. Count, if we go start counting, that will be too much. But one thing, any possible transition between any two orbitals, it can be done. So from selection in mathematics we know nc2. Out of these n shells we are supposed to select any two, and all those transition or all those spectral lines will be available, especially corresponding to those transitions will be available. So our answer is going to be 5c2, giving us 5 into, like we can select any two like this, and we can do this by this way or simply by counting this, like possible transitions are going to be this, like that, and if we go start counting, that will be too big a number. Now finding this value here is going to be answer. Next question here. So electron here we have, and we have a line charge if you see. We have a line charge if you see. Now, electric field due to a line charge is going to be 2k lambda by r, which is equal to 2k is 1 over 4 pi epsilon naught lambda by r, and this value comes out to be lambda over 2 pi epsilon naught r, giving us lambda over 2 pi epsilon naught r, and this should be equal to mv square by r because it is undergoing circular motion, giving us v is equal to root over lambda divided by 2 pi epsilon naught r m. Now, time period, if they're asking, so time period is going to be 2 pi r divided by speed. So 2 pi r divided by lambda over 2 pi epsilon naught rm, giving us t is equal to, so this becomes 8 pi cube epsilon naught m r square by, wow, one more thing we missed. This is the field only. I have to multiply with charge also. So lambda q will get. So lambda q. So our answer being 8. Moving on, we have a simple pendulum, and this is a distance much larger than the surface. So time period of simple pendulum is 2 pi root over L by G. In this case, we have to write down some t prime, which is going to be 2 pi root over L by G prime. The G prime, the G value at that location. Now, G value at the surface is equal to G mass of the Earth, mass of the, and divide by radius square. And this G prime is going to be G, same mass, but now distance here is 2r, giving us G prime is equal to 1/4 of the value on the surface. So from this we can continue and write down T prime is equal to 2 pi root over L divided by value on the earth by 4, like that, giving us T prime is equal to 2 pi root over 4L. Now the value of L here is said to be 4 meter, and the G value is going to be 10. I can write this down as T prime is equal to 2 pi root over 16 by 10. Simplifying it will give us T prime is equal to 2 pi root over 8 by 5. And if you see, we have in the same format, so our x value here comes out to be 5. Moving on, this is one of the good questions, I would say. Now, drawing the FBD of the charged particles, I'm choosing only one side for now, theta. If I draw the FBD, I'll see that there will be some weight and electrostatic force. Now, good thing here is they have said that the situation is such that the separation between the particles is not changing. So electrostatic force is going to be same. Now, extending the lines here, this angle is going to be theta. Drawing a perpendicular here, this angle will also be theta. Now, and this is tension T. In the other case, if I draw, I'll have the same mg, which I can be write down as rho Vg, where rho is the density of the particle. So mg, which is equal to rho Vg. Now in this case, the electrostatic force of repulsion here will become Fe by K. K is a dielectric constant because the medium has changed, so we have to change the electrostatic force. We have a tension some T prime, and in this case we'll also need to include the buoyant force, which will be sigma Vg, where sigma is the density of the liquid itself. Now if I extend these lines, this angle is given to be theta, I'll take theta, and if I draw a perpendicular line here, now these angles will also be come out to be theta, and this also theta. Now in case of equilibrium, forces perpendicular to the string here, forces perpendicular to the string must balance each other. So from the first case I can write down Fe cosine theta is equal to rho Vg sine theta. That's the first equation. And second, I can write down Fe by K cosine theta plus sigma Vg sine theta is equal to rho Vg sine theta. We can rearrange to write this down as Fe by K cosine theta is equal to rho minus sigma Vg sine theta, giving us the second equation. Now dividing equation 1 with 2 gives us K is equal to rho over rho minus sigma. So putting the values here. So rho is, again, relative densities are given 1.4. If we multiply density of water here, that will get cancelled. So I can directly put relative densities here. 1.4 divided by 1.4 minus 0.7 for the liquid, giving us 1.4 divided by 0.7, answer being 2. So 2 is the answer in this case. All right, this was the last question. Thank you, everyone. Again, keep in mind, this is a memory-based question paper, so there may be some errors in the question, but we have tried our best to deliver the best possible content. Thank you.